design the crosshead assembly. Isometric view of the assembly is shown here. First of all, we will start with the part modeling. So at first we will design the body of the assembly. We'll start from this view. So I will produce this rectangular feature which is 115 by 30. Okay. So here I go, start mechanical design, part design. I will enter the name of my part as body. I will select the sketch tool, this plane as my sketch plane. Rectangular tool, place the rectangle. I will make these two vertical lines symmetrical about this vertical axis using symmetry constraint. These two horizontal lines symmetrical about the horizontal axis using symmetry constraint. I will place the dimensions. This is 115 and height of this rectangle is 30. Let us check the dimensions. Yes, it is 115 by 30. Sketch is green, that means it is fully constrained. I can exit the sketcher. So I will add the material on both the sides of sketch plane using mirror extend tool, and depth of my material is 210. So 210 divided by 2 on both the sides, so total is 210. Next, I will select the vertical plane as the sketch plane. We will draw one circle whose radius is 115. Okay, and distance of center of the circle from this edge is 165. Okay, so I have drawn this circle which is having radius of 115, and the center of this circle from this edge is 165. Now I will draw these two vertical lines separated by distance of 80. So I will use the rectangular tool. So this is my rectangle. So distance between these two vertical lines is 80. So we'll change the value to 80. I'll make these two vertical lines symmetrical about the vertical axis using symmetry constraint from constraint definition toolbox. Next I will draw one more rectangle here, and distance between these two vertical lines of my rectangle is 60. Okay, and this line are symmetrical about the vertical axis. So I will apply the constraint of symmetry. What I have drawn this portion, two vertical lines separated by 60. Okay, now this is here, so we'll apply the constraint of coincidence. Now let us trim the unwanted elements by using quick trim toolbar from operation tool. I don't want this, this is gone, okay. Now here, not interested in this, I don't want this, as well as I don't want this. Okay, now I can delete this line, as well as this line. So this is my sketch which is green, that is fully constrained. So I can exit the sketcher. I will add the material on both the sides using pad command and mirror extend tool, and the thickness of my material is 100. That means 50 on both the sides of sketch plane. So this is my feature. Okay, the next we will draw this rectangular slot. For that I will select this as my sketch plane, select the sketch tool, draw one rectangle. Now height of this rectangle is 45 and its width is 8. This is on this, so let us apply the constraint of coincidence. This is on this. So we'll apply the constraint of coincidence, and now I will place this edge from this edge at a distance of 165 minus 45 divided by 2, that is 165 minus 22.5. So it is 142.5. Exit the sketcher, add the material, reverse the direction, depth of material is 80. Okay, now I will draw this slot. Okay, so we'll select this as my sketch plane, select the sketch tool. First of all, we'll complete the shape of my component or feature using the profile tool. Okay, now this is vertical, so let us make this as vertical. This is horizontal, so apply the constraint of horizontal. Radius of this arc is 40. Okay, and distance of center from this edge is 40. Okay, and this is here, this is on this edge, so apply the constraint of coincidence. The center of this arc from this edge is 165. Okay, so I've done with this sketch. Now I will remove the material using pad tool throughout the body. Okay, now next we have two holes separated by distance of 150 mm and diameter of each hole is 30. So I will select this as my sketch plane, select the sketch tool, fit in all, draw one circle having diameter of 30, so radius is 15. Draw the another circle, radius is 15. Center of this circle is on this vertical axis. Center of this circle is on vertical axis. So we have applied the constraint of coincidence. Now select the centers of both the circles. This one and this one, and distance between these two centers is 150. Okay, and this hole is at 90 mm from this upper edge, so center of this hole from this edge is 90. And here all the elements are now green. Sketch is fully constrained, so I can exit the sketcher. I will remove the material using pad tool up to last. Okay, so I have done with the holes. Now we will fillet the edges. Okay, this is having fillet of 20 and this edge is having fillet of 5. Go to the dress of features, select the fillet tool, select this edge, this one and that one, and change the value to 20. Next, select this edge and this edge, fillet 5. So here is my body. Okay, so let us save this. I'll create the new folder, say crosshead assembly. Next component is key plate. So let us draw this. First of all, we will start from this view. We will draw the circle of 220 millimeters of diameter and these two vertical lines separated by 80 millimeters. So start mechanical design, part design. I will name the part as key plate. Sketch tool, vertical plane as my sketch plane. Circle, diameter of the circle is 220. Okay, let us check whether we have given diameter radius. Yes, it's radius, so I want diameter as 220. So let us change the dimension to diameter and value to 220. Okay, next I will draw the rectangle. Make these two vertical lines symmetrical about the vertical axis using symmetry constraint. Distance between these two vertical lines is 80. Okay, so it is 80. Now I will trim the unwanted elements. It's 80 and 220, correct? So 80 and 220. So select the trim tool from operation toolbar. I don't want this. I don't want this. Okay. Trim this one, and this one, and these two lines. Now I can delete this and this line. Now we have two holes. So this diameter of this hole is 30 and center of this hole lies on this vertical axis. So we'll apply the constraint of coincidence. We have one more hole, so I will use the mirror tool from operation toolbar and select the horizontal axis, which will be my mirror plane. Now distance between these two centers, it is 150. Let us check. As it is 150, so we have done with the key plate. The sketch is green, so I can exit the workbench. I will add the material using pad tool on both the sides using mirror extend option. Depth of material addition is 35. So 35 divided by 2 on each side of the sketch plane. So total is 35. So I will save this in the same folder by the name of key plate. Now start mechanical design, part design. And next we will design this piston rod. So I will start from this view. So circle of diameter 220 and these two lines separated by 80. The name of my part is piston rod. So I will name the part as piston rod. Select the sketch tool, vertical plane as the sketch plane, circle whose diameter is 220 and one rectangle. Make these two vertical lines symmetric about the vertical axis using symmetry constraint. Now the distance between these two vertical lines is 80. Now let us trim the unwanted elements using quick trim tool from operation toolbar. Don't want these, don't want these, not this, not this, this and this. Now I can delete this two lines. Next we have two circular holes of diameter 30 and distance between the centers of both the holes is 150. So this is one hole whose diameter is 30. Center of this hole is on this vertical axis, so I'll apply the constraint of coincidence. I want one more on the other side, so select the circle and choose the mirror tool from operation toolbar. Select the horizontal line as the mirror plane. Now distance between these two centers is 150. Okay, so I am done with this. I can exit the sketcher. I will add the material using pad tool on both the sides using mirror exchange tool, and the depth of material addition is 35, so 35 divided by 2 on both the sides. Now let us draw this circular feature having diameter of 60 and depth of 75. So we'll select this as my sketch plane, select the sketch tool, circle from profile toolbar, place the circle, dimension is 60. So sketch is green, I can exit the sketcher. I will add the material using pad tool, and depth of material addition is 75. Okay, on one side of sketch plane. Now next we'll produce this slot of 45 by 8 on this surface. So select the surface as the sketch plane, select the sketch tool, take the rectangle tool, draw one rectangle, make these two horizontal lines symmetrical about the horizontal axis using constraint of symmetry. Now this is along this, so apply the constraint of coincidence, and this edge is on this, apply the constraint of coincidence, and now this distance is 45. Okay, let us check it. Yes, it's 45. Sketch is green, I can exit the sketcher. Now I'm going to remove the material using pocket command in this direction up to the depth of 8. So this is my slot. So we are done with this piston rod. So let us save this with the name of piston rod in the same folder. Now we'll draw the another component. Next component is the brass. The views are shown here. So first of all we'll draw this middle one. The cross section is shown by these hatching lines. So let us first of all draw the shape. So start mechanical design, part design. Name of my component is brass. So I will select the sketch tool, vertical plane as my sketch plane. So I will complete the shape using the profile tool from profile toolbar and sketch tools. So this is my sketch. Radius of this feature is 40, and I will align the center of this arc with the origin of coordinate system using coincident constraint. This line is horizontal and distance of the center from the left hand side edge, okay, of this edge from the center, it is distance of this arc whose radius is 40, okay, whose radius is 40 is 52, correct? So this is 52. Let us check once again. So 52, we are correct, and this is 48. Sorry, this radius is 48. Sorry, 40, correct? 40, and this is 52. Okay. So I can exit the sketcher now. And my sketch is green. I will add the material using pad tool on both sides of the sketch plane using mirror exchange tool, and the depth of material addition will be 80 plus 12.5 plus 12.5 total. So on one side of sketch plane 40 plus 12.5, since we are using mirror exchange, so 40 plus 12.5 on each side. Okay, next I will select this as my sketch plane, sketch tool. So now I want the same sketch, so Let us use the project 3D elements from operation toolbar. I want to project these edges. Now I will use offset tool from operation toolbar to offset this profile by some distance, and this distance is 8. Now this is my sketch. So outer radius is 48 and inner radius is 40. So 48 minus 40 is 8. So offset distance is 8. So let us add the material in reverse direction, and the length or depth of material addition is 12.5. So I want the same feature on the other side. So I can go to the transformation feature toolbar. I will use the mirror tool and select the center plane as the mirror plane. So I'm done. Now we have the circular hole in this feature. So I'll select this as my sketch plane. Sketch tool. We'll draw one circle whose diameter is, the diameter of circle is 65. So change the value of diameter to 65. Center of the circle is on horizontal axis. So apply the constraint of coincidence, and center of this circle from this edge, let us check, it is at 15. 15. Done. Remove the material using pocket command up to last. So we have drawn this component. So let us save this in the same folder. So file, save with the name of brass in the same folder. Now next component is, so the next part is bolt. So we will draw the bolt using the concept of revolving features. So it has two steps. First step is of 20 and second is of 230 minus 20. So let us go. Start mechanical design, part design. I will name my part as bolt. Select the sketch tool. I will select the vertical plane as my sketch plane. Profile tool. Start from the origin. One step and second step. Okay. Now let us give the dimensions. The length of first step in horizontal direction is 20. So let us edit this value to 20. Length of second step 230 minus 20. So 230 minus 20. So it is 210. Now let us dimension the diameters or radius of rotation of first step. The radius is 45 divided by 2. So it is 22.5, and the radius of rotation of second step, it is 15. 30 divided by 2 is 15. Now the sketch is green, that means it is fully constrained, so I can exit the sketch. Let us use the shaft tool from sketch best features. Now let us select the axis of rotation as horizontal axis, and this is my component. Okay, so this is my bolt. Let us save this with the name of bolt in the same folder. This component is nut. So we'll proceed. This is a hexagonal nut and this dimension as 60. So here I go. Start mechanical design, part design. We'll name my part as nut. Select sketch tool. will select the horizontal plane as my sketch plane. Go to the profile toolbar, select the hexagon tool. I will select the origin as the center of my hexagon. I have oriented my hexagon. Now I will dimension it from this edge to this edge, and that distance is equals to 60. So let us change the value to 60. I'm done. I will add the material using pad tool on both the sides of sketch plane using mirror extend tool, and the total depth is 35. So I will enter here 35 divided by 2 on one side of the sketch plane. So total is 35. Okay. Now I will select the sketch plane, this one ZX, then sketch tool. Okay, I want to make this arc of radius 10. So I will go to the operation toolbar, select project 3D elements. I will project this edge, then this edge. Okay, then I will go to corner, select this edge and this edge, and place the corner, and now radius is 10. Okay, then I will edit the value of this radius to 10. Then let us trim the unwanted elements. Okay, let us repeat this. I will project this edge. Next, the fillet. Now I want both of these edges, so I will select this. Okay, this, place it. Radius is 10. Use the trim to delete unwanted elements, and here I am done. Exit the sketcher. I will use glue command to remove the material. I will select the axis, vertical axis for rotation, and this is my nut. There is one hole in the center of nut having diameter of 30. So I go to sketch tool, select this plane as my sketch plane. Go to circle, and the dimension of that circle or hole is 30. Let us check it. Yes, it's 30. Sketch is green, fully constrained. I can exit the sketcher. I will remove the material using pocket command up to the last, and here is my pocket. Let us save this file in the same folder by the name of nut. Okay. Components of crosshead. This is the isometric view. So first of all, we will import the body. So I will start mechanical design. Now select assembly design. We change the name of my assembly as crosshead assembly. Okay, go to the existing component tool in the product structure toolbar, select the assembly title, browse to the folder and select body. Select body, will apply the fixed constraint using constraint toolbar. Check the component degrees of freedom, so it is 0 since we apply the constraint of fixed. Next, existing component assembly name. I will import the brass. Go to the move toolbar, select manipulation tool, manipulate the brush, select coincident constraint, this axis and this axis coincide, and contact this surface and this surface. Okay, then contact this surface with this one and update. Check the component degrees of freedom. So it has only 1 degree of freedom of rotation about x-axis, and it's okay. We want to keep it. Select existing component, click on the assembly name. Now we will import the key plate manipulation tool. Move the key plate at appropriate location. Coincide constraint. Select axis of this circle hole and axis of this hole. Coincide axis of this hole and axis of that hole. Contact this surface with this and update. Okay. Check component degrees of freedom. They are 0 and it's okay. Now next, existing component, click on the name of body. Now let us import piston rod, manipulation, manipulate in y direction. Okay, so coincide constraint this axis with this and coincide this axis with this. Contact this surface with this and update. Component degrees of freedom 0. That's okay. We don't want to move this piston. Now existing component, assembly name. Now let us import the bolt, manipulation tool in y direction. It's okay. So we have to insert bolt from piston side. So coincide this axis with this and contact this surface with this and update. Okay, go to the assembly features, select symmetry tool, and this axis as axis of symmetry. So before that, let us select this bolt, symmetry tool, and this horizontal axis as axis of symmetry. Finish. Next, existing component, name of your assembly. Now we'll import bolt. Sorry, we will import nut now. So existing component, name of assembly, and nut. So manipulation in y direction, in z direction. We will rotate about the defined axis. So I will rotate about this axis. Okay, done. So coincident this axis with this and contact this surface with this and update. Okay, go to the assembly features toolbar, select symmetry constraint. So first of all, we will select the nut, symmetry about this horizontal axis. So repeat this, nut, symmetry, and this plane. Finished. So this is assembly of cross head. let us hide the planes x, y, z, z, x for body. Hide brass, hide key plate, piston rod, bolt, okay, symmetry nut or symmetry of bolt, then nut. So let us hide the planes, then symmetry of nut, hide. So this is my final assembly of crosshead.